So last time we looked at a best fit line. And the purpose behind the best fit line was to figure out, since I've got all these points that I can't get an exact line through, what would be the best at going through most of the points? And when I can't get through all the points, I say, okay, how close can the line be to all the other points? And we did that with a simple housing problem where we figured out what the purchase price would be in the year 2010 based off of data from 1990 through 1998. There were two pieces of information we didn't use that appeared on the calculator screen. One was R and then second was R squared. R stands for the correlation coefficient. And basically what that R value is telling us is how well will the line fit the model. And we go from -1 up to 1. And really what we care about is just how close is it to 1. If it's a value of 1 or -1, it's going to be a 100% fit, meaning that every single point is going to be on the line. The closer I am to 1 or the closer I am to -1, the better the fit for the line. So something that would be considered a bad fit would be if I was from 0 to 35. That's what's known as a bad fit. Something that's an average fit, or sometimes referred to as a good fit, would be 36 through 74. And then something that's considered an excellent fit would be 75 through 100, with 100 meaning every single point is going to be on the line. So this correlation coefficient is going to tell us how well does the line fit the model with the given points that I've got. R squared is the coefficient of determination, which tells us how good will the future outcomes be. If my points that I've plotted get further and further away from the line as the values get larger, the smaller this coefficient of determination is most likely to be, because our points are getting further and further away from the line. And so this, looking at future outcomes, it says, okay, how good is it going to be? If I have something that's a 98 or 0.98, that's going to be pretty good in the future. But if I have something that's 0.2, I really can't rely on that at all to give me anything for the future. So example number 2 is we want to plot the following piece of information about the average football salary and determine the best fit line for the equation. How good of a fit is the line, and how accurate is it in determining future values? Here, this is actually 2003. I can see I've got duplicate 2001s right there. So the first thing we're going to want to do is we're going to want to plug all these values into the calculator. We're going to want to set the window for these values so we can see our points. Then we're going to want to choose a linear regression because it specifically says here the best fit line. And once we've got the linear regression, we've got the pieces of information that we're going to use. So let's start by plugging in these values into the calculator. So we go to Stat and then Edit. And I've gone in ahead of time and typed in these values. Once again, I let 0 equal 2000 and 5 equal 2005, just so I'm working with smaller values with my years. And then on the right-hand side, I've got my values in terms of hundreds of thousands of dollars for salary each year. 787, 986, and so forth, all the way down to 1405. Now, if I look at these points right here, I can see 0 to 5 are my extreme x values, and my y's, I'm going 787 to 1405. So when I set my window, 0 to 500 is way too much. Maybe 0 to 6 is all I need. The x scale will be 0.6, because that would be slightly larger than the 5. And then the average salary, let's go a minimum of 750, since that's slightly less than the 787. And then 1405, that could be 1450. And if I look at that, that's 700 values between the max and the min. So if I take 1/10 of that, that would be 70. Got to go back to Stat Plot and make sure my plots are turned on, which they are. My x value being list 1, my y value being list 2. And then I can hit Graph and I can see my points right there. There's all my values. Now I can see there's no way there'll be a straight line that goes through all those points. Here it's looking pretty linear with these 3 points, but then this one's off, and this one we can see is way off. So I want to find the best fit line. And the way we do that is we go to Stat, and we're going to choose Calc. And under Calc are all our options for the different tests we can do. Linear regression, quadratic regression, cubic regression. Since we're looking for a line, we're going to choose linear regression AX plus B. Here I can see list 1 and list 2 is that list. That's perfectly fine. We'll choose calculate, and I can see the information there as A being 120 and B as being 857. This looks slightly different than the one I did in my previous video because this version of the calculator has the newer operating system. If you have the one where you just hit linear regression then choose OK, you'll get the exact same result. But also I can see here I don't have my R and R squareds. So in order to turn those on, I need to go to my catalog. So what we do for that is we hit second, and then we go hit the button 0 down here. We can see it says catalog right above the 0. And then we're going to scroll down to the D's. And under the D's, we're going to choose diagnostics on. And diagnostic on will turn on my R squared values and my R values. So let me go back now, and I'm going to go to Calc, Linear Regression, and I'm just going to choose Calculate. And now I can see, oops, I chose quadratic right there, so I don't have an R value. I want Linear Regression, Calculate, and there I can see my R squared and my R value. So I want to know what is the best fit line for the equation. How good of a fit is this line? Well, the best fit line, since I'm in the format y equals ax plus b, I can see here A is 120.114 and B is the 857. So my best fit line is going to have a slope of 120.114 and B is going to be 857.714. So there's my best fit line. How good of a fit is the line? Well, we get how good of a fit it is from the R value, which is 0.969. And the way we want to look at that is that's a 96.9% match, which is really good. And how accurate is it in determining future values? That's our R squared value, which is 0.939, which is pretty good at predicting the future. So this linear correlation looks to be correct in determining what the future salary would be.